Yay. So in this video, I was going to go over how you can keep yourself, what am I trying to say, safe when it comes to, we're looking at the idea that people have, which I covered in another video, that you cannot protect your local secrets from Claude. In other words, Claude or any LLM is able to access what your local secrets are. And so this diagram kind of walks through how we can prevent that. And we're going to get into this in a moment. The other thing we're going to look at today is this chart. I mean, this is so cool. I'm like just I'm taking chats that I've had with Chat GPT. Usually I use it like in a planning capacity, and then these are just turning those chats into diagrams that we can follow. So this is a separate layer of secrets management, which, the popular tools out there are HashiCorp Vault, and then just using GCP secrets, or to use the AWS Secrets Manager. But I'll go into like where my research was on this in terms of cost and why I decided, I just want to build this myself. But that's it. We're going to go over those two simple concepts today. And so let's look at it. So the way this one works is when we go to SSH into our box and we're going to run some code, or like, let's say we're just working on our local and we have Claude. This all comes down to user management. So there's this idea that you're going to have basically a user that is more privileged, that owns the secrets. And we're going to see this concept when it comes to the secret server as well. But this privileged user is able to then bind a real SSH user's environment such that, let's say Claude, you're at least gating access to the secrets file. And so what you're sort of saying is that let's say let's say my username is Mike, and then I have Mike hyphen secrets, right? And so Mike hyphen secrets is the only service or user that's allowed to access the secrets file. And so I am logging into my box as Mike. My LLM user is basically operating as Mike. And basically, what we have is a contract where when I log in through SSH, we're going to do what's called a PAM hook. And the system, which is it's like closer to, I don't know at what layer exactly SSH operates, but it's probably close to the kernel. So we have kind of something closer to the kernel that's basically saying, okay, I can talk to both Mike hyphen secrets and Mike, and I'm going to sort of broker here a key that you can use as Mike to then tell Mike secrets, hey, give me the secrets. And then under these gated circumstances, I will let you do that. So that's the general concept here. So that's the idea where like you can gate access to your secrets through, like, let's say a binary. You could do like run secrets or like mount secrets and then your command, for example. And so that's how you kind of would prevent Claude, or at the very least, Claude would, not be capable of reading your files, not be capable of committing them in any useful form. So you have secrets leakage that way. And this should be like a more productionized way of thinking about this. And I have to say as well that this is in addition to anything that you would ever accomplish with HashiCorp Vault or with a secrets manager. Those tools at the end of the day assume you're doing something responsible with your secrets. And so let's go into this. So here on the left, we have SSH user that is basically logging in. Their identity is proven. Just a normal shell. Then there's the step-up unlock. So the operator runs the unlock program, which talks directly to like this Mike hyphen secrets user who let's say is like running a server or whatever, just some kind of service. It could communicate in any way. We don't really care. And so it's basically going to, user Mike is going to talk to Mike Secrets, and then Mike Secrets is going to say, okay, cool, your symmetric key works, meaning like they just typed in a passcode. And whoever is running it could be Mike Secrets, we trust. So they sort of say, okay, I'll give you a short-lived server-side lease. And it's basically, this run folder is special in Linux, and I actually wish I could tell you the details, but I'm not totally sure why it's choosing the run folder. I think run has some specific importance. So here they're kind of saying that it's tied to the owner's UID. And this is where I think it's sort of saying that it's tied to the PID of your SSH session, which is perfectly possible to do. And so you could sort of say that unless the user is running from within the SSH session, which I don't know, I kind of think if you start just running an LLM, it's also going to be attached to your SSH session. So it's not bulletproof. But I think that's how I had been prompting it in the LLM. So I don't know that this piece is actually possible. But the general gist here is still going to be okay. So then we go to requesting an action. So this is where I said you come up with a binary, like in this case, it's calling it safe run. And you would call it like mount secrets, because that's what it's really doing. It's saying, I'm going to go get the secrets and put them into the environment variables. And this is, whenever I've used HashiCorp Vault, it works very much similarly. So, and then here, this is just saying like to create like a session on those secrets, but really like at this point, like, and then it's talking about auditing, like when are the secrets accessed? But really at this point, all it's doing is it's mounting the secrets into environment variables. So that's the step right here. So secrets injected, and then it's just injecting it into the environment. Then this thing down at the bottom here, session expiration. So this is basically just saying like, it's just making sure you don't leave any, valid sessions dangling for someone to reuse or hijack. And that's about it for that chart, actually. But yeah, it sort of says at the bottom, like this protects against, we could try to make this bigger, but it protects against like untrusted processes that are trying to basically, well, I would say it's also protecting against, it could protect against an LLM that you don't really trust, as like it might make a mistake, it might commit it to Git. So it doesn't live in a file, like it lives in a file that's owned by another user, and then you could think of it like you're having like a network boundary in there where you have to get authorized access to go talk to that user. So the key principle here, like where does the security come from? It's this idea that you never really have the secrets file in your OS user that owns the processes that are executing things. They have to kind of go out and make an explicit call to get access to that secret, if that makes sense. And so that's the general gist of it. The weakest part of this that I kind of mentioned is this idea that we're going to bind it to the actual SSH session. It was something like I chatted about, but the reality is if you're going to run Claude as part of your bash terminal, like unless you're doing something to detach the process, like this wouldn't really be a valid way of enforcing it. I think the thought that I had was like, you could definitely ensure that like some other malicious SSH session or some other process that somehow got spawned, wouldn't be able to go and mount those secrets. So that's within the realm of, like it's possible that it helps some things. But it's a nice to have. It's not the core piece of security here. And I mean, like going back to like why, where were we? Yeah, why build this thing like in the first place? Because I think if you use Vault, you might get something like that. But the reality is that like there's such a difference between like just having Vault on your system and then like using Vault to just download your dev environment secrets or something. It's complicated to set up. And it's important, I think, if you're trying to be agile, to try to get something that's quick, that doesn't require all that enterprisey stuff, but gets you most of the benefits rather than just you. But the alternative, obviously, is to use like a cloud method. But again, it's kind of like the same problem. It's like if you just have your users process like permanently connected, anytime you get onto that system, like you have your GCP keys or whatever, and it's like it has indefinite access to call the secret, like what's the point of that? But look at this table right here of the cost. It's like kind of even worse. It's like 40 cents per secret per month. And GCP is significantly cheaper at 6 cents per version of a secret per month. And it's like every time you access that secret, which means like you could be just testing things, like you're going to get charged for that. So like that's the motivation of like why would we build this type of system? And so now let's tackle like it's not the bigger system at all. It's probably the more pivotal of the two systems. So we're looking at building here. This is just like a secret server. And so similar concept to what we had with the last security concept was you have this idea of separation between which user is the runner. In that case, it was Mike, and then which user owns the secret and brokers access to the secret. That user was like Mike's secret. So it's kind of the same concept here. We have basically a server now that can run its own what's called a machine-to-machine credential, which is using all of the standard flows of standard authentication. So authentication is a well-understood problem. And so once you can sort of prove identity of someone through like, let's say an M2M token, you could do anything from a two-factor auth type of challenge to sort of have a client connect to a server and sort of create a request for, hey, these are the secrets that I want. Maybe you give them access to like see what secrets there are available. And then you can make a request as a machine authenticated, let's say user. You're really a machine in this case. And then an authority, which is the owner of the secrets, could then kind of manage and approve any requests coming in. And that would create kind of the equivalent contract that you get with GCP. But again, remember, 6 cents a secret per month, 40 cents a secret per month. And you have to kind of do all this stuff eventually anyway, right? And so it's kind of like here, what you're doing is you have, there's a couple other nuances of this, right? So it's important if you're the server manager or the manager of the secrets, you don't really like, there's this concept of encrypted at rest, which I think gets thrown around too much. Encrypted at rest helps with one aspect of things, but really you want it always encrypted. You want it encrypted. Yeah, I don't know if you'd call it like, you wouldn't call it in flight to the browser, but like certainly you don't want it unencrypted in your database. And I don't want to get into the topic of why encrypted at rest is kind of a misnomer, because but the short answer is that the reason it's a misnomer is it usually refers to like your machine or VM being off, which is like not what people expect. So you want the real encrypted at rest, meaning that when it's in your database, it is completely encrypted. And so you want this concept of a layer where the user enters a password let's say it could also be a two-factor auth, you know, or it could be something that's like public key, private key. It's just something that basically decrypts or has the capability to decrypt the data from the database, but in a way where I guess the reason that two-factor auth might be more challenging is that you'd have to implement. Yeah, how would you ensure the data? Well, whatever. I'd have to look at the protocols for that. The idea is you're doing something though to keep the data encrypted at rest. And then that's the basic gist, that once a user, your security in this system comes from, and you're enhanced over that other model that we looked at. In this case, your main security principles is again separation of which user owns and brokers access to the secrets, and then which user runs the secrets. And then what you get here, that's it's similar to the other pattern as well, where you're going to mount the secrets every time you run the application. So you're never storing it on disk with the runner user. But the other benefit here is that you're now centralizing your management of secrets, and you're as well, that gives you a better ability to do things like rotate secrets. You can sort of centralize looking at who has access to secrets. You can do things like as well, like we talked about, the idea of submitting a request for like, hey, I'm this identity and I want to have access to these secrets. So you can scope which secrets are kind of in use by which identities. And so you can kind of limit horizontal damage if there was a breach of the system. It's kind of the key concept. The other concepts that I actually pulled up in research, but we can actually flip on next, is this idea of egress. You could also set up a system outside of these bounds, and I will probably, out of scope of this video, not get to this concept, but you could make sure that secrets never egress. The weakness with that one is that if a user has access to the actual raw secret, then they could kind of reconstruct this to get around egress rules. So that's the limitation of that defense. And then what was the other concept that I was going to circle around? And then, yeah, you have this concept of rotation of your secrets, which I can't believe that as I was like kind of researching this topic, and like, of course I know and have used Vault, or like, I've used whatever secrets manager in GCP and AWS. It's like, here's another huge misnomer. It's like, if you don't rotate your secrets, and you can have policies, and I've definitely worked in organizations where there's policy that says like, hey, this is only valid for so many months. Which is a good thing to do, because then really in theory, all you're doing is you're just updating, you're creating a policy upstream, and you're saying, hey, this service is only going to work for 3 months, and then it's going to stop working. You guys are going to have no access, and like you're going to need to go do a rotation or whatever. So that is one of the most important things. And then the idea of having a server like this is you can easily redistribute what those secrets are to all of your identities, if that makes sense. So same concept, you'd get this with GCP, you'd get this with Secrets Manager. It's important to understand these things. And as well, it's like for someone like myself who's trying to broker services to people, it's not cheap at whatever it is, 40 cents a month. Sorry, 40 cents a secret per month. But yeah, let's look at this diagram. So here it's saying that we have a web dashboard, REST API. We have the auth service. This seems like it's just addressing nouns. We have the Vault unlock service, which is kind of that idea I mentioned. It could be a public key, it could be a symmetric key. This has this program I think I've seen before, but it might be trying to kind of identify the concepts of what I'm saying with something more industry standard. Here, yeah, this is just saying like the capability, the secret service is kind of the capability of the thing to just create new secrets and manage secrets. Here's the authorization and policy layer of it's saying who can do what, which VM can access which secrets, which is tied to that M2M token. Here you say, yeah, this is just recording who got what when, who ran what when, mounted secrets when. Here's that VM identity service that I mentioned, where you sort of approve, hey, this identity is allowed to access these secrets, or that's this next box, which is the request and service grant. We can make this a little larger. And then this is sort of just detailing like what the database looks like for this. And then key flows, what do we got here? User authentication, vault unlock, kind of something I had mentioned, to never keep your data, especially secrets. You'd never have those unencrypted. VM registration and requests. Yeah, same thing I mentioned, managing secrets and approvals. It's all kind of, and then secret retrieval will be like at runtime. It seems like this is more of just a ChatGPT images thing, which is interesting. But I guess it's taking this secret retrieval by VM and it's labeling it with the number 4 here. So this is saying the VM authenticates and retrieves only the secret is granted access. And then this just shows like right here kind of what it looks like when a VM just requests a secret, which is pretty straightforward. So continuing on, VM authenticates with its identity, token pub key submits manifest. Yeah, so I think I've covered this pretty well. Yeah, and I think I just wanted to. I think some people kind of they're building with AI and they don't really understand what it's doing, and they don't as well like understand that sometimes they're doing things that maybe leave themselves vulnerable. And there's a lot of like reasons by which, like, if you just prompt GPT, be like, make this ultra secure, like it might just work. Or if you sort of, another easy thing you can always do is just generate penetration tests against your website or your app or whatever. I helped a colleague of mine, he had an app he launched, he vibe coded, and it was like super easy to reverse engineer the API so that I could like grant myself 1 million tokens in his system. So, it's, I covered on my last video as well. It's like, I mean, this is a separate security. This is more from supply chain attacks, but it's like, there's just so many different things that, ways you could be compromised digitally, but there's also these practices that I've covered in this video, which, I mean, these are just structures of security that are just well known. And it's kind of like, you learn over time that there's like, so many levers of whether you're learning about like blockchain and you're learning about different ways that they do proof of work, proof of stake, or whether you're talking about like, you're watching some like fiction spy thriller and there's like the concept of a dead man switch is like the ultimate form of leverage, because I think the dead man switch works where like if the person dies, then like harm comes to other people. So no one wants to kill the bad guy or something. So that's kind of how security works. It's kind of like you're doing a mix of structural reasons. You're trying to limit, if the system's compromised, how far they can move horizontally. You're obviously trying to lock down holes in your system that allow someone to escalate or like vertically breach. And then there's just, through encryption methods, which, that's a different topic as well, because then you got to start talking about quantum and all that stuff. But my understanding is that there is like I think it's like the EDC method. I'm going to get this so wrong, but it's like, they say it's quantum proof. I don't know. But, just try to do what you can to protect yourself and try to understand security concepts as well, which that's, I think, why I'm making a video on it, is because it's just not straightforward stuff. All right, till next time.